And before we start, I'd just like to introduce Dr. Clara Barker, and she actually manages the Center for Applied Superconductivity in the Materials Department at the University of Oxford. She's also the Vice Chair of LGBTI Plus Advisory Group there and has won the first Diversity Role Model Award. Also, she's been a recipient of the Point of Light Award twice in 2018 and 2019, which was given to her by the UK Prime Minister, and she's been an active voice in promoting the LGBTI plus rights and runs the youth group of the LGBTI plus young people. So I'll just give it to Dr. Clara Barker now.
Awesome, thanks for that. So I've actually got a presentation, so I am going to share that. Hopefully I'm sharing the right screen, because otherwise that could be embarrassing. So do let me know if that seems to be the right screen. I believe so. So yeah, as I was introduced, I'm Clara. I'm a material scientist at Oxford University. I will also say I've got a lot of things on my opening screen. I'm the chair of the LGBT advisory group at Oxford University. I'm the Dean for Equality and Diversity at Linacre College in Oxford. And I'm also a member of the Royal Society's Equality and Diversity Committee. And I have a YouTube channel, and I do YouTube stuff and Twitter stuff and Instagram stuff. I think that more and more we're seeing scientists particularly are using social media, and it's all about using the right social media and how you use it. And I will actually mention a few of those groups later, especially as there's been a couple of conversations about networking, especially in a sort of pandemic world, as it were. So just before I start, I'm going to mention what is material science, because some of you will probably go in, what is material science? We're not really known. You take a little bit of chemistry, you take a little bit of engineering, and you take a little bit of physics and smush them all together. And we are a hybrid science. We are a mixture of all of those. We are somewhere at the intersection between those different subjects. And often I will work in a chemistry department or a physics department or an engineering department. Luckily at the moment I am in a full materials department, which Oxford has, which is kind of nice. And just a little bit more on what we do, because hey, what can I say? I like it. If you imagine that you have carbon and you've got those atoms, we know that depending on how you arrange those atoms, how they are bonded, how they are joined together, we can change the properties of the material we have. So if you take carbon, you could have graphite, which is very soft, it's a dark grey material, or you could have diamond, which is very hard and transparent. And so what we as material scientists are trying to do is manipulate those bonds to try and change the structures. And yeah, so that's my job. And I generally work with thin films. Thin films are everywhere, and I'll probably talk about that a little bit throughout my sort of, as I'm talking about my career. So basically on a day-to-day basis, I'm in a lab with these bits of equipment, which half the time they're covered in tin foil, and they look crazy. We've actually got two of these machines now. This is a pulsed laser deposition, thin film deposition system, which is really cool. So it relates to photonics a little bit, because I'm firing a big old laser at pieces of metal to atomize it, basically. If I'm not firing a laser at it, I'm applying a very large voltage to it, and we get these really cool plasmas, plasma being another state of matter. And so, yeah, basically we're trying to manipulate our materials on the atomic layer, and then we grow thin films that might be about maybe a micron or 200 nanometers thick. Once we get to 2 micron, that's huge. I don't want anything to do with that. That's massive. It's far too big for my liking. Now, I took a very unusual path. My career has been very unusual, and it even started at school. So I was very lucky that I went to a grammar school. However, I grew up on a council estate in the north of Manchester, and I was a weird kid. I was often bullied and frequently beat up, and I knew that whilst I'm not saying that comprehensive schools or local schools are not good schools, the ones in my area that I would have been allowed to go to were not. And so my mother did all she could to get me into a grammar school, put me forward for the exams, And I was very privileged to do well enough to gain a scholarship, because we would not have been able to pay for me to go to this school. So I had a really good basis at school, which was fantastic. And like I say, I don't think, because I was quite a weird kid, I was bullied a lot. So I would have struggled at a local school. It's as simple as that. And so I went to a school that was supporting supporting me to do well academically. But that doesn't mean that it went, without issue. I enjoyed my time at the school, but the truth of the matter was that I am transgender. Now, admittedly, at the time, we didn't have the words, we didn't know this. I grew up in the 90s and the 80s and the 90s, so we had no internet, we had 4 TV channels, so we didn't know the word transgender. If we saw LGBTI plus people on the TV, they were a joke or there were something wrong with them. They certainly weren't any role models. And in the UK during the 80s and 90s, we had a law called Section 28, which meant that you weren't actually allowed to talk about LGBTI plus people. You weren't allowed to promote homosexual lifestyles or trans lifestyles. So we had this weird thing where it was actually illegal for our teachers to be able to talk to us about it, sort of. So I didn't see anyone around me at school, which meant that I got very, very depressed and my mental health suffered. So I did my GCSEs, but then my A-levels, which are the next stage at the school in the UK, I actually dropped out of school. I didn't finish school. I couldn't. My mental health was bad and I just wasn't able to concentrate and work as hard as I should have done. But I knew that I had some sort of smartness to me, and I knew that I could potentially do well. So after a few years of working in bars and nightclubs and lifeguarding and DJing in the centre of Manchester, I actually got myself onto a foundation course at the Manchester Metropolitan University. I got onto a foundation course in engineering. And then from there, I went on to do an undergraduate degree in electronic and electrical engineering. And I thoroughly enjoyed that. It was really, really great fun. But what I will say, that we were in this big, huge engineering block, and looking around on my year, there was one person that we knew was a female on my course, just one. And we had no female or women lecturers at all. And even, we had the male bathrooms were on every floor and the women's bathrooms were on every 3rd floor. We didn't even we weren't even set up to have more women in engineering, never mind actually do it. So it was quite an unusual situation. And so that meant that I felt, even though I still knew that I was transgender, I felt that I had to hide that, and I just kept it to myself, which, isn't great for the old mental health. During my engineering degree, I actually got to work for a company called Bobst. So I took a year out working with Bobst. Bobst make vacuum deposition equipment. So this is where I got into the material science side of it. Basically, if you have a packet of crisps, it's a piece of plastic with metal on the inside. They made the machines that put the metal on the inside of those machines, of those packets of crisps, to keep your crisps fresh. And these are quite big machines, to be honest. The one that's in the picture was actually clear barrier, so it meant that you could actually see your crisps while they were staying fresh. And I ended up working on this machine for quite a long time. And in fact, once I'd graduated and completed my undergraduate degree, I was offered a full-time role at Bobst. And the point was that I had this opportunity. It was quite an unusual opportunity during my undergraduate, but I took it and I worked hard. I was slightly lucky with the timing, but I made the most of that opportunity. And to the actual point where I started doing the electrical design work, and then I got into the engineering development, and then I got onto the material engineering side of it. I was flexible and I looked at what was interesting, and these fields were all related. So I was able to change and move throughout the different fields. And I talked to everyone I could. I was polite and I worked hard. And at the end of that, I got offered, I was suggested for a PhD. ironically, back at Manchester Metropolitan University, where there was this really great material engineering group under Professor Peter Kelly. So because of the contacts, because I'd worked hard, and because I'd made sure that I did meet people and chat to people and be friendly, more opportunities came up. And so the advice that you've heard throughout the day is similar. You've got to chat to people, but you've also got to work hard when you get those roles. So I went to work with Professor Peter Kelly at Manchester Metropolitan, and we were making thin films. So I used a system called magnetron sputtering, and the thin films we made were for, I'll give some examples of some, you don't have to worry about what these graphs are. That's not really the point, but these were for photocatalytic things, so for solar cells and things like that. During my time at Manchester, during my PhD, we were looking at, there was quite a well-funded EU cost action. So this was a European project aimed at bringing people in my particular field together. And so I had the opportunity to travel to lots of meetings around Europe and work with different groups. There was funding available, which I applied for. So I got to work with a group in Germany for a few weeks, and I got to work with a group in Denmark for a few weeks. These opportunities were there. I met people at conferences, I talked to them, and I struggle to talk to people. I should say I'm quite insular. I'm quite happy with my own company. But when I'm at conferences, you know, I had to put myself out there. I had to overcome my uncomfortableness and talk to people, which I did. And so I got to work with these different groups. And in fact, at the end of my PhD, while I was writing up, I got a visiting fellowship post at Lappeenranta University in Finland, in a place called Mikkeli, which is in the middle of Finland, where I was growing more thin films. I did a lot of thin film work. It's all thin film work. But that was because I'd worked with the group, and then I did a couple of weeks working with them, you know, chatting to them, and then I went out and did a couple of weeks work with them, and then they offered me a visiting post for a few months while I was writing my thesis. And it was really nice and calm in Finland. Where I was, it was very quiet. So it's good, a good place to write, although it was very hot. After this, because of the work that I'd done with different people, somebody got in touch with me and said that they had a postdoctoral position at EMPA, which is in Zurich in Switzerland. And so they got in touch and asked if I'd like to interview, which I did. And I did an online interview because it was quite a long way to travel at the time, and I got the post. So I went out to Switzerland, to EMPA, and I did more work, kind of more of the same. These were all electrical waveforms. But again, I continued to do this collaborative work. So I worked with, I went out to Uppsala University, and I worked with all different people. I brought someone from Mons University in Belgium to come and work with me. I kept those collaborations up, and I kept going to conferences. That's not always possible. There's not always the funding. I was quite lucky in my field. There was the opportunity to travel around the world to conferences. And because it was an emerging field, there was always a lot to talk about as well. But it's kind of interesting that we've talked a lot about papers, and there's been a lot of discussion about papers. But my field was very experimental, which meant that most of my experiments failed. We didn't get good results. For me, getting papers out was hard because we didn't have enough good results to really publish. Unfortunately, in some fields like particle physics, it's quite common that you publish null results or negative results. I did a lot of experiments, but I didn't always have positive results. And in material science, that wasn't publishable. So I worked hard and I did a lot of experiments, but it isn't always possible to publish in your field. And, you know, in my field, the type of films that I was working with, they weren't necessarily sexy materials. They weren't the sort of headline science that, you know, would get into Nature or science journals. We had our own field. We had our own small impact journals, But that's where everyone looked at those fields. Within my field, you were more likely to get cited in these small impact journals than something in Nature. That was just the way the field is, which is why it's really difficult when for jobs they just want impact factor, and it's like, well, we don't really have it just because of the nature of the science that I was doing. So it changes throughout the field. Now, during this time, I was, still struggling with my mental health. There's no two ways about it. And as scientists, we don't always help people with their mental health as well as we could do. And I actually was finally able to admit that I was transgender. But I didn't think that I could get a job in science if I was transgender. And the reason for this is, by this point, I'd been working in engineering and material science for 14 years. And in that time, I'd met 2 out gay scientists and no trans scientists or engineers. And bearing in mind, I was traveling around the world, I just didn't see that visibility. I didn't see anyone that was transgender. So I assumed that I had to make a choice between transitioning, being myself, and being happy, and science. And so whilst I was doing my various postdoc positions in Switzerland, I decided to choose me. I decided to choose my happiness. So I didn't, towards the end of my postdocs, I wasn't writing my fellowship applications. I wasn't publishing my results, few and far between that they were, because I decided that I had to look after myself. I had to think about myself. Now, as a scientist, not publishing and not at least trying to get fellowships isn't a great idea. And, it sort of will kill a scientific career, to be honest. You don't have to have you will get a lot of knockbacks, and the rates are going to become harder and harder in a post-COVID world. But you do still have to be at least trying and putting something out. And I wasn't. Then, so I transitioned. I started living my own life, and I saw a job, a technical job, managing the Centre for Applied Superconductivity at Oxford University. And I only applied for this to prove how horrible everyone was going to be to me now that I transitioned. And wouldn't you know it, I came along to the interview and everyone was really cool. Everyone was really nice. No one actually cared. They cared more about the work that I'd done, the scientific work that I'd done. Now that's how it should be. We should only care about the scientific output. But I'd made the assumption, because I didn't see anyone like me, that I couldn't continue to be a scientist. So when they offered me the job, I was really, really surprised. So much so that they actually raised the wage because they thought I was haggling. I wasn't. I just didn't expect them to give it me. So now I'm in the Centre for Applied Superconductivity. And what I will say is I've started working with various people that I used to work with, and everyone's been really cool. Everyone's been really nice. I haven't had the trouble that I thought. So I make superconductors, and in my lab I've got, in fact, actually I can see it now, I've got this bed of magnets and a superconductor in a little polystyrene cup with liquid nitrogen. Superconductors are these things that float. I will say this is a bulk superconductor, not a thin film superconductor, but we do make thin films as well. So I said that I sort of almost sabotaged my own career because I assumed that I couldn't be myself. And a lot of times we talk that, just be yourself in science. We don't care about who you are. We don't care about your gender or your race. All we care about is your output. People often say, just be yourself. But we actually know that this isn't true. Now, if we look at LGBTI plus scientists, it's a little bit hard to find LGBTI plus scientists throughout history. Because if you didn't come out, if you didn't tell anyone that you were LGBT, you weren't seen. We can't write about it in the history books. It's the same with disabilities that are hidden. So Alan Turing was a fantastic mathematician, attributed to doing lots of great work on maths and helping, apparently, help stop World War II a little earlier. But when it was found out that he was gay, he was convicted of it because it was actually illegal at the time. He was chemically castrated. He was his work access was revoked. We should say that Alan Turing was a fantastic mathematician, and he hadn't finished working. He was still young when he took his own life because of how he was treated, because of who he was. There's a fantastic physicist called Sally Ride. She taught at Stanford. She did an awful lot of work for women in physics. But it was only when she died that people found out she'd been in a same-sex relationship for 20 years. She never lived authentically or openly as a gay woman. And there's in medical science, in neurobiology, there's this guy called Ben Baez, who I don't claim to know anything about neuroscience, but apparently he's awesome. Whenever I mention him to people that do neuroscience, they're like, he was amazing. They've all followed his work and cite his work. Extremely distinguished career. But he talked in his autobiography about how he thought he couldn't be transgender, how he couldn't transition to male, and thought about taking his own life. He didn't, and we had this amazing output of work, but we almost lost a fantastic scientist. And we see this a lot. Women only make up 23% of people in STEM. And in some fields like engineering and physics, it's very, very low. The Nobel Prizes that we've awarded to women, there's not very many. There's 51 women and 831 men, 853 men. And on average, a lower proportion of female academics earn the higher wages as well. So most of the women that are in science earn lower wages. And there's lots of reports on this. And we see similar things with people with disabilities. People with disabilities make up 22% of the population in the UK, but only 2.6% of the population in STEM fields. And that's only 4% in academia in general. And people with disabilities are 60% less likely to stay in STEM. We can talk about race. We know that, you know, in the UK, there's 14,000 male professors and only 90 are black. There are 4,700 female professors and only 25 are black in the UK, in all academia. And actually, there's a lot of reports that BME men are less likely to stay in STEM and that there's actual discrimination. It's not just that they're not working in the field, they're actually facing discrimination when they're there. 60% of black people in STEM have said they have faced active discrimination. And it's the same with LGBTI plus people as well. Only 40% of people don't tell anyone that they're LGBT, that they're gay, they're trans. And a lot of people in physics have been told to stay in the closet. And we know that there's a knock-on effect that LGBT people are less likely to stay in STEM. They're more likely to leave. And that's on top of race, on top of disability, on top of gender. And luckily, we're starting to see the societies take note. The Institute of Physics, the Royal Astronomy Society, and the Royal Society of Chemistry did a big survey a couple of years ago, and they showed that LGBT plus people are being discriminated against. And what is the effect on science? Well, LGBT scientists are talking about leaving science sometimes, 30%, compared to only 16% of non-LGBT people. And when it comes to trans people, 20% of trans scientists are actively looking at leaving science. And remember, I was one of those people. So it means a lot to me. Don't know why we've gone backwards there. So why is that? Well, it's because we have all these things. There's a lot of work for equality, gender equality in physics, and yet there are still some people who feel that they can say that men are better than women at physics, that all the work, all the discoveries in science were made by men. And yes, that might be true with physics, but that's because women weren't actually allowed to study science. So of course men made more discoveries. That's just how it is. And if you're wondering, Oxford University is just celebrating 100 years of allowing women to study at Oxford University. So yes, if men made more discoveries in science and physics, it's because they were allowed to, which is remarkable. And even with race, we're seeing pushback. And unfortunately, we see other signifiers as well that push more people out. The Institute of Physics had more people, white men named Brian, for their last round of fellowships than women and BAME people, which is quite remarkable. And this is the IOP, I work with them a lot. They do a lot of great work, but they're not giving out their fellowships. So I think it's quite important that we are visible. I believe very much in being visible. I've learned that since I wasn't kicked out of science and it was all right, and a lot of my worries and my lack of career progression was because of thoughts that I had about how I would be perceived. I try and be as visible as possible. I've been to some strange places, and I've done a TEDx talk on why we need to be actively diverse in academia as well. I also believe very strongly that we should all have hobbies. Mine is painting nerdy science, fantasy figures. These are all miniatures. I believe very strongly that we should have a life outside of science as well as inside it. Apart from anything else, it keeps us fresh. And you're saying, well, do we need to be active in diversity? Well, various banking groups have found that the more diverse their groups are in terms of gender and women, the more profit they make. So actually, diversity seems to be showing that we have more money. And in science, it seems that groups that are more diverse are actually being cited more often than less diverse groups, which means that the quality, the output of those groups as a diverse group is better. So from my point of view, the more mixed ideas you have, the more thoughts, the more diverse the group of people, the more new ideas you'll have, the more fresh ways of looking at things. And like I say, it seems like science is actually better for actively having diversity. So I'm not going to go into this, but there's a few things. It was interesting we talked about should you move around. We've got to remember that not everyone can move institutes to do a postdoc. If you've got a family, if you're supporting a family, maybe your social economic background means that you can't move to different countries like I did. I think that's less and less becoming something that you have to do. I think more and more we're seeing that you can go from PhD and stay in the same city or the same university for postdocs, but you might have to work a little bit harder to get your own funding. As for the internet, well, we're all locked down, so there's a lot of great things out there. There's a lot of online groups supporting women in science and days supporting that. There's different days supporting various groups. And I think Twitter groups are really, really important. Groups like Tigers in STEM, who are active for all diversities in STEM, and groups like Black Women in STEM and 500 Women in STEM and 500 Queer Scientists. You're not always going to be able to find a mentor in your field. You're not always going to be able to find someone that you can talk to. And you might have a good professor, but you might not, but you might need to talk about something maybe to do with your diversity. So being able to network online and look at these groups online and engage and find more support. Social media can be pretty grim, but it can also be a fantastic place of support. And especially at the moment where we can't go to conferences and meet people, then getting involved in scientific discussions on Twitter, as long as you keep it, sensible and thoughtful and professional, it can be a really good way of getting your name known and getting invited to do talks. And it's nice that the societies are starting to sort of look more active diversity as well. So with that, I think I've probably gone quite long with my slides. So feel free to get in touch. And thank you so much for listening to me.
Oh, thank you so much, Clara. That was really important. Thank you so much once again. And before I jump to questions, there's a wee message for you from Sophia in the chat.
Yep. Awesome.
Right.
There's not many of us.
So just moving to the questions, but you did mention, and I think this is something that needs to be asked, is what steps could academia take to encourage and empower people who were previously non-represented?
I think it's important that we start highlighting our scientists. It's important that we start to make sure that when we host a panel, when we have invited speakers at a conference, we make sure that it isn't 90% white males. Now, that's not saying that if you're a white male, you don't have a place and you shouldn't talk. That's not true. What we're saying is that we want to make sure that more voices are heard. Because for me, it was really important not that I didn't see role models. And that gave me an impression of how my career would go, and I ended up stopping. So we need to have role models. So it's important that we do bring speakers through. And it's not that there aren't good speakers that are black or that are gay. It's just that they're not necessarily being thought about. And so just taking a little bit more thought to make sure that if we've got talks, if we've got conferences, that our lineup is actually, you know, diverse. It's as simple as that. You know, we still, like I say, there's still been a couple of conferences and fellowships awarded where most of them have gone to white men. And like I say, that's not saying that they're bad. It's just saying that really, you know, when we've got more white men called Brian getting a fellowship than women and BAMing people, it seems like there's a little bit of a problem. And I could understand if, you know, I don't expect to see lots of trans people in the world because we're a very small percentage. But when it comes to women in STEM, that's 50% of the population. You're talking 20% of the population is disabled. You know, we need to be in line. 10% of the population is LGBT. We need to sort of be seeing that our figures in academia are in line with what we're seeing in the general population. And that's why, and as I said, women have been allowed to do science for 100 years, and we've got to 23%. So I think that just allowing people isn't enough. We need to start improving it, and we need to be more active. And it's great to see initiatives aimed at, you know, looking at race and reevaluating what are we doing to push people out of science. Unfortunately, though, I still think in academia, in some universities, academics who bring in a lot of money can get away with a lot of what they want. I see this a lot. But more and more people are standing up and shouting and getting together and going about it in the right way. Doesn't mean that we go and burn down our universities. You know, we've got to be constructive. I want to see constructive things. I don't want to see us tearing down one person. I want to see us building up other diverse people. Professor Chris Jackson is going to be the first black person to give a lecture for the Royal Institute. And he has received so much racism online. I know him, and so I've seen a few of his personal emails just for being the first black person to present. What? And people say that there isn't racism in science, that it's free of it. It's remarkable. So yeah. So and there's some people that get so much grief for talking about gender in science as well. Jess Wade is a fantastic physicist who, you know, I see her, what the grief that she gets online for just saying there are more women around. And you've got to think of our privilege. It's like, we're not saying that we, you know, you might not see a problem with race in physics, but if other people are, why is it constructive to say that there's no such thing? Why is it constructive to publish a paper saying racism doesn't exist? You might not see it. Maybe that means that you're not talking to, you know, maybe have a look at your friend group.
Yep, totally. I totally agree with you there. And
thank you, Glo, for that lovely comment. And also, Sophia, there's some, it's a good place to be. I enjoy it, but we still have things to change.
that's true. Yeah, I think that's also the end of time. And so I'm not going to take any more time. But thank you so much, Clara. Again, that was so informative.
No, thank you.
And thank you to Sophia and Miles, who's not here, for being a part of the event. It was lovely having you. Yeah, and again, thank you so much for all the attendees who came in. Thank you so much for your wonderful questions. Just as a last bit, also like to thank Scope. I didn't mention at the very beginning who's collaborated with us for the event. We're going to do 2 more webinars on this, and the other one's going to focus on industry, and then the last one is going to be a miscellaneous webinar. Please join our Facebook page or Twitter page. It's very easy to find us. And thank you once again for being here. It was an honor to hear from you.
Thank you. Thank you, everyone, for listening.
Thank you so much.